Yeah, good afternoon, everyone. My name is Hari Yadav. I am a senior researcher at IIT Delhi. My area of research is consumer analytics, and all my webinars are inspired by the research that I'm conducting at IIT Delhi. Today, we are going to discuss if anyone have the curiosity to know about my work. My all the work and my portfolio are mentioned on my LinkedIn profile. I work in the both the technical and the conceptual aspects of consumer analytics, and also mapping that what kind of business applications the consumer analytics delivers to different domain of businesses. Recommendation engines are the most integral part of the consumer analytic projects, and with the recent development of GPT-3 models, today we are going to discuss that how the recommendation models can be leverage the capability of GPT-3 and can make more interactive, more user interaction could be done, and how they can increase the efficiency of the existing recommendation models. So I'll just share my screen so that we can start the discussion. I hope my PPT is visible to all. Yeah. So recommendation models are work. We will start with some basic introduction and some familiarity with the concepts which are very important in the recommendation models, and then we get back to the code. The similar package you can find at Cellstrat Hub into my pack of consumer analytics with the GPT 3.5. Apart from that, today we are going to discuss one case study and some conceptual concepts which are important to recommendation engines and how they work, evolving that the customer interaction with the business platforms. So a recommendation models basically works where we identify customer preferences and we make a point of differentiation at the time of purchase. So we know that customer have their own journey of purchase where the customer is divided into three phases of purchase, where we have a pre-purchase journey, we have where the customer interact with the product or service, and then we have a post-purchase journey of the customers. Now, at the time of interaction with the product or service of the customer, recommendation engines work really evidentially, where they are known to increase the conversion rate, they are known to increase the average order values, they are known to increase the customer retention, they are known to increase the repeated orders from the customers. So this is one of the major facts that recommendation engines are most widely applicable into the business domain. Now talking about the customer centric businesses, for example, the entertainment businesses, for example, the e-commerce platforms, for example, the education, the edtech platforms, for example, Coursera. For them, recommendation engines work more precisely and more effectively because of the fact that they have huge product depth and as well as product line with their business. So most of the time, recommendation engine should be mapped with the fact what kind of product portfolio you are having. So if you have a huge product line, then maybe you are going to do a recommendation based on the product association and as well as the user association. So basically what we are doing here is that we are trying to map and we are trying to predict the customer preferences at the point of interaction of the customer with the product or service. So for example, if we take the example of Netflix, so back in 2006, Netflix offered a challenge to the data science community to improve their recommendation engine algorithm by 10% and win $1 million. And in September 2009, the winners were announced, and they use matrix factorization method to build the recommendation engine, and as well as they use the collaborative filtering method to improve the algorithm, to improve the efficiency. So basically why it is more important, as we discussed before with the consumer complaint classifiers, it is also uploaded at the Cellstrat platform, that when you say that you are going to predict a preference of a customer, and when you say that you are building a recommendation model where you want to increase the average order value or where you want to increase the conversion rate, it is really important, specifically with the recommendation engines, that the loss metric you are using should be very accurate and the loss should be very minimum. And that is also the reason many of the times we see a lot of open community competitions coming up. Recently at the Amazon research scholars, we have this interaction with Amazon International Relation Manager, I think Rajiv Rastogi sir, where he mentioned that how huge, I think Amazon has built 10 million product node platform where they are building recommendation on that kind of product metrics. So this is also important to understand that what kind of product portfolio you are having and what kind of recommendation you are proposing to your customers. So basically, recommendation systems use rating that users have given items to make specific recommendations. Companies that sell many products to many customers and permit these customers to rate their products. Now, for e-commerce platforms where they have huge variety of brands, where they have huge variety of products, it plays a really point of purchase differentiation role. So, for example, for me, if I'm going to Myntra, then the brand that I may prefer, if I'm seeing what kind of products are coming to those specific brands, maybe my interaction with the platform, my interaction with Myntra will increase. So that may be the reason that we see a lot of application of recommendation engines to e-commerce platforms. Again, Netflix is an example of entertainment platform where it's heavily dependent on the kind of recommendation they are doing, because the more recommended movie they are proposing to their customers, the more retention they are having, the more customer churn will decrease. So basically, we are trying to say that the more customer-centric businesses or platforms you are operating into, the more advantageous recommendation models will be for you. So basically, the categorization of recommendation models are done into three categories, where we have the content-based recommendation models, which is more implicative in the kind of business of education, where you go to the platforms like edX, you go to the platforms like Coursera, and you will find that if you are looking for courses, let's say into deep neural networks, learning a skill, then more recommendation will be done to that specific category of the course. And if I talk about the collaborative filtering models, they are more they most of the models work in a hybrid way, but more of the collaborative filtering models are applicable into e-commerce platform, because they have both the data collected. They have your ratings, they have your web footprints, and also they have your the what kind of delay time you are spending on watching a product. So most of the web footprint data are collected, and on that data, most of the times collaborative filtering models work more precisely. Another example is deep learning based models. Now, the deep learning based models are more implicative, as I discussed that in the recent Amazon Research Scholars Conference, they mentioned that they are using huge graphical neural networks to build the recommendation models, and they are dealing with now the advantage with Amazon is that they have a huge capacity to invest into product, analyzing each product as a graphical node, and establishing that kind of structured network day of their pre-processed data set. But most of the time, if the businesses, the small businesses or the medium businesses do not have that kind of capacity to build that kind of pre-processed data networks, the most of the time content based and collaborative filtering methods work more precisely for them. So that depends upon what kind of data volume you are handling with, how structured your data is, and how you have actually captured that data. One of the most important metrics that we need to understand is the loss function. So apparently what here we are talking about is that a platform is going to recommend my preferences, right? So let's say I go to a Big Basket platform, and I open the app, and the Big Basket is going to recommend what product I may buy, or I require, or according to my preferences. Now, the difference between the actual product that I like and what the platform is suggesting me, the more the difference is less, the more accurate the model is going to predict my preference, right? So it's something that if the model is not predicting what actually my preferences are, then I may not buy that product. So I can say that the loss function, or the kind of prediction or kind of recommendation you are doing, is heavily dependent on what kind of calculative loss functions you are using. The less the loss functions you are actually approaching into the model, the more precisely you are going to predict the preference of your customers, and that means that more precisely the conversion is going to happen. If you are going to predict a product to a customer which the customer actually like, more precisely the customer will buy or subscribe to that service. So in my personal experience, if I could say, I have been chased by Netflix a lot of times. Whenever I try to unsubscribe the Netflix, they try to recommend me movies which are very close to my specific choice, and sometimes they do get me because they are so good. Their algorithm is so good, actually predicting that what kind of movie genre I may watch, that I sometimes continue with the subscription of Netflix. So that is how the customer retentivity is also attached with the fact that what kind of loss function and what is the accuracy you are trying to predict with your recommendation. So one of the most common used loss function into the recommendation model, which was also used into the Netflix challenge. I will attach the paper also. This, you can find all the details of the Netflix challenge that happened, and how the team was actually, how the team designed the model, and they were actually about to reach, I think, point 0.8 something accuracy. So it was not too much, but they were actually they improved the accuracy by I think 0.8% something. So you can find the details here. I will attach this detail, so anyone is interested about the whole challenge, and the data set is also available there at the given link. Again, coming back, so here we are seeing the root mean square error for the regression task, and most commonly we used mean squared error as well. And for binary cross entropy, for binary classification tasks, so there are a lot of loss functions that you will come across. Now it depends upon uh, your choice of what kind of recommendation model we have built. Is the recommendation model is calculating cosine similarity? Is the recommendation model is based on a content base? So you may have actually built on TF-IDF scores. So what kind of recommendation models you have chosen depends, and then again you need to cross check that what kind of accuracy will be more preferred for your model. So in the simple mathematical formula, we can see that if n, the root mean square error is given by the fact that where n is the, with this formula, where n is the number of instances, yi is the actual rating for the ith instance, and yi bar is the predicted rating for the ith instance. So basically, the less the value, the more close you are to the fact that you are actually suggesting, actually recommending something to the customers where the customer originally wants to buy. Now, there are some other metrics that we also discussed, or we also need to aware about the recommendation models. So recommendation systems loss functions plays a crucial role in training models by quantifying the difference between predicted and the actual values. The choice of a loss function depends on the specific task and the model architecture. There are some commonly used loss functions. Most commonly used loss functions are mean square error, the mean absolute error, and the binary cross entropy loss. So the mean square error is basically commonly used in collaborative filtering and regression-based recommendation models. The mean absolute error is also most widely used in collaborative filtering and regression-based recommendation models, whereas the binary cross entropy loss is more suitable for the implicit feedback scenarios where interactions are binary. So what is the difference between implicit and the explicit feedback scenarios? So for example, the implicit feedbacks inputs are the inputs which are taken by the web footprints of the customer. So for example, the delay time of the customers, the click of the customers. So these are very noisy data sets. So basically you are tracking your customer behavior across your website. So where your customer is surfing across your website, what are the clicks, how much time they are spending on the product. So these kind of inputs are considered into the implicit feedback inputs, whereas the explicit feedback inputs are more appropriate because they are the ratings, they are the reviews they have provided. So these are more structured and less noisy as compared to the implicit ones. And most of the times, the most advanced form of recommendation engines are built taking both the implicit and the explicit feedback inputs. Some other loss functions which are also used are point-wise loss for ranking. In recommendation scenarios involving ranking, point-wise loss function focus on individual instances rather than pair or triplets of items. The pairwise ranking laws, where the pairwise ranking laws functions focus on pairs of items and aim to correctly order them. List-wise ranking laws functions consider the entire list of the item and aim to optimize the order of the entire list. So these are some of the loss functions that you may consider meanwhile building your recommendation model. Also, you may require 2 3 loss functions, and you may compare the accuracy between these loss functions. Now, considering the implicit and explicit feedback, the type of recommendation systems, as I discussed, that the what kind of implicit and explicit feedback influences what kind of choice of loss function also depend upon what kind of input feedbacks you have taken, and also on the model architecture. The loss function may vary based on the architecture of the recommendation model, that is the matrix factorization, neural collaborative filtering, and again the content based as well. The selection of a loss function depend on the specific goals of the recommendation type and the type of the data available and the underlying model architecture. So for example, in case of content based recommendation models, you are more concerned about the fact that in let's say in today's example, if we are going to take the Zomato data set, so in today's example we are going to explore the restaurants which have the similar reviews as similar high reviews and similar positive reviews. So we are going to recommend restaurants and the food and the cuisines to the customer with the similar reviews given by the customers. So in that scenario, your loss function calculation may be very different as compared if I take a user rating, a particular metric of user rating for a particular restaurant. So most of the times collaborative recommendation engines work well. So they are based on the two fundamental concepts, where user-based collaborative filtering is performed or the item-based collaborative filtering is performed. So just imagine it like a way that in user-based collaborative filtering, what we are doing is, let's say there is a user A, there is user B. So let's say that user B have shared the similarities and the similar preferences with the user A, and on that basis, you are recommending the user with the similarities of the other users. So if user A and user B have similar preferences, then user B, like a movie that user A hasn't seen, right? So the system may recommend that movie to user A. So it's something, basically we are mapping the users' similarities among themselves, and then we are recommending something. So for example, Big Basket, if I am buying something, if I'm buying something which is very sugar-free products, I'm repeatedly buying. So maybe there is another user who share the same preferences or same buying patterns into one category, and the product they are buying may be recommended by the model to me, so that I may also be interested into buying something which is under the same category of sugar free product. So item based collaborative filtering is also based on the different concept, where what we are doing is recommending items similar to those the user have liked in the past. So basically what we are doing is that if a user likes a particular movie, then the system recommends other movies that are similar to the liked movie. So this is also similar with the one concept which I discussed before, is the market basket analysis. So there is a strong correlation between the products. Some products are bought in patterns. Some products shows that, so it's more common where you have huge product depth. So like unlike Big Basket, so because they have huge product depth, they have huge product width, so they can identify which are the product categories or which are the products who possess a very strong correlation among each other. So in that scenario, the product can be recommended. So you will see a lot of recommendation patterns when you go to the website. There are items bought together, or you see most rated items, or you see that items that you may like. So these are the three category of recommendation. You more of the times, if you go to Amazon, you will see that the recommendation work into three different ways, but they are trying to actually engage, they are trying to actually come by closer to your preferences. So the item based collaborative filtering work on the kind of the item rating which is provided. How the similarities is calculative now, that depends on what kind of metric you are using. Either, so one of the most discussed and one of the most understood way of measuring the similarities is cosine similarity, Pearson correlation, and the Jaccard similarity. Now, the Jaccard similarity, if someone is interested to actually learn more about Jaccard similarity, there is a very good course on edX. The huge, then it's like mining big data set. It's from, I think, Stanford, if I remember correctly, mining huge data sets. The course name is like that, and they have explained Jaccard similarity in a very good way. So if you want to, even they have also explained cosine similarity in that course material. So these metrics measure the similarity between users or item based on their preferences. Very simple calculation, how we calculate the cosine similarity, that we have done in our school time as well. That if there is user 1, where it has rated movie A, B, C, D, and there is user 2 and user 3. So let's take the form of the vectors from the user. So user 1 may be written as 5402, user 2 is 0345. And if we calculate and if we perform the dot product of these two users, then we can have a dot product value. And similarly, we can calculate the magnitude of the two users. So the magnitude of user 1 will come up by this formula, and the magnitude of user 2 will come up with this formula. And if we calculate the cosine similarity with the applying the standard formula, it will give us 0.623. Now, that means that it's a moderate level similarity. So the cosine similarity of 0.623 indicates a moderate level of similarity between user 1 and user 2. The range of cosine similarity is between -1, completely dissimilar, and 1, completely similar, and 0, representing no similarity. So basically here, what you are trying to do is you are trying to calculate the similarity, and then by using maybe the nearest neighbor methods, the KNNs, and you are going to propose the similarity of the most similar and the most nearest neighbor of your item. The second recommendation measures may be used with Pearson correlation. Pearson correlation works with the, I think, covariance, and the Jaccard similarity works with the set theory. So these three are the most applied way to calculate similarity between items. Now, the suitable for capturing non-linear relationship is more cosine similarity and is not sensitive to magnitude differences. So it depends upon what kind of data attributes you are taking, and on that measure, you may choose that what kind of similarity index you are choosing to calculate. Pearson correlation coefficient captures linear relationship but may be sensitive to outliers. So please make sure that you see your data set, that how the data set is, you explore your data set fully so that you calculate the similarity on the basis of the characteristic of data that you have. So it is often used when the data is centered and has a Gaussian distribution. With Jaccard similarity, you are suitable for binary data set, for example, user item interactions, and measures set similarity. And then as we discussed, that the neighbor selection is done, identify the k most similar user or items to the targeted user or item, and then we do the recommendation. Now, the parameter k is the number of the neighbors to consider, and it can be turned based on the application of the recommendation engine. So today we are going to see the code, and today we are going to discuss that how GPT-3 can be used for a content-based recommendation model to augment the way the content-based recommendation model are built and they interact with the customers. So one aim of the present webinar is that how we can leverage the GPT-3 models or the LLMs into building the existing customer analytics models, and how they can increase the efficiency as well as the interaction between the customer and these models. So the basic steps today we are going to follow is the data preprocessing, which is very relevant as in case of classification and the complaint classification models as well, that we have done in the past. And then we will do some kind of a data cleaning, because we are using a content based recommendation model, and I have done a work into this area. My preferences are more aligned with the content based model, although the accuracy measures are not great. But when you try to let's say you have a huge corpus of customer reviews, and when you try to analyze that what your customers are preferring, and then you try to build a recommendation model, as of my understanding, it creates more customer centricity in your businesses. So basically you are trying to understand your customers, and you are trying to recommend on the basis of what the customer is actually wanting. So all the quantifiable metrics, that is rating and that is the footprints, may be accurate, but I think the content based recommendation models are more customer centric, because most of the times we use customer reviews and to as an intrinsic part to build the customer based recommendation models. Now the data cleaning part we are going to follow with removing unnecessary columns and duplicates, as we do very widely with the language models. And then the text processing, applying the text processing techniques, including removing URLs, stop words, and punctuation. Then we are going to create a TF-IDF metrics to represent the textual information of restaurant reviews. As I said, that we are going to use the reviews data today to build the recommendation model. So we are going to identify this metrics to represent the textual information, and to also identify the similarity calculation between the TF-IDF metrics to via using cosine similarities between restaurants based on their reviews. Now, TF-IDF has a huge implications in building recommendation model, and also identifying patterns into huge corpus of reviews, or maybe huge corpus of the Twitter data or any textual data. So it actually gives you the more thematic overview. So for example, if you have 100 tweets or 100 million tweets, then TF-IDF metrics can give you that what are the theme which are revolving around the huge corpus of the data set. Recommendation functions, implemented a function to, then we are going to build a recommendation function to recommend the similar restaurants for a given restaurant name. Why we have chosen this step is because of the fact that, let's say a business is involved into providing food delivery, or Zomato as a business may prefer that, due to the logistic cost involved, they may want to recommend customers based on the location base. So for example, if I am residing into Saket area into Delhi, then Zomato will preferably try to recommend the restaurants which are nearby my locations, which have the similar cuisine preferences, and which have the similar kind of customer ratings as with me. So we have used the cosine similarities to identify and rank similar restaurants and displayed the top 10 recommended restaurants. And also we have then augmented the code with GPT-3, that how we can leverage GPT-3 to actually enhance the recommendation of the model. So for example, let's go with the code. So these are the general steps that we have followed: the fine tune IDF, TF-IDF parameters, explore additional features. So in the present code, I have also performed the collaborative filtering based on the user rating, because we had the user rating in the data set. But in the Cellstrat platform pack, you may not find the collaborative filtering part. It was just done to just make sure to just show that how the collaborative filtering model works. And we can also always advance the embeddings. We can also explore the use of advanced word embeddings techniques like word2vec and glovies to actually capture more nuanced relationship between words and improve the representation of restaurant reviews. We can also do it by using network analysis. We can in R there is a library called network X which is used to perform that. And also we can perform the collaborative filtering that we have done. Let's go with the code. I think then we will be able to explore more. I hope the screen is visible. Okay. So I have used the Zomato recommendation system. I have used the Zomato rating dataset and the Zomato dataset, which is available on the Kaggle platform. So you can go and try to fetch the data. It is, I think it is it. The data is very old. It's not new, if I'm sure. So we will start with the importing libraries. So we will start with the importing necessary libraries. So we are going to use sklearn model selection module for model selection and evaluation tool. We are also going to use import the natural language toolkit. Now I'm showing this on Google Colab because I have actually augmented the code with collaborative filtering, but the self-strat hub also have the same code, so you can go there and you can run and you can play with the data. You can play with other kind of analysis if you would like to view, if you would like to do. Then we have,
Yeah, I had a question. So, with the
yeah,
advent of large language model,
yeah, yeah.
is the whole thing disrupted? The idea of collaborative filtering or content or item based filtering. Uh,
No, I do not think that with the advent of LLMs, it is disrupted. More of a kind, I think it is augmented. It can be made into better way. It can be made into more interactive way. But I would not consider it as a disruption. I would consider it as a augmenting tool. I would say that we will see it today. That how we can leverage GPT 3.5 to
I mean, when
actually.
I said disruption, I meant replacing the traditional collaborative filtering based technique and using LLMs exclusively for recommender systems.
I will still. I don't think that we can replace the whole collaborative filtering model with the LLMs, because I think it's more specific. So we do a lot of feature engineering before actually coming up with the final recommendation model. So in that, I still believe that the traditional way might work more effective. We
Got
can
it.
augment it, but not fully. We can replace the systems. So yeah.
Got it. Got it. Thank you.
Um, So beginning with the fact that we'll mount the drive and then we'll load the data set. So let's see the data set, that how it looks like. So we have rate, we have the rating. So this is the rating. We have 4.1, 4.1, 3.8. We have the address, we have the URL in the data set. So this is the indexing, I think, done. We have the name of the restaurant, we have the phone number, the location, the rest type, the dish like, cuisines, and the review list, menu items, and the city also. So just to have the idea that how the data set look like. Now the next step would be to actually identify and contain the concise information, that what to identify what kind of missing values we are dealing with, and also the what kind of data types of each columns are. So for instance, the rate column has some missing values, so we can see here the rate columns have some missing values as well. So this is something, this is step is to just ensure that what kind of missing values we are dealing. So let's proceed with the data cleaning and feature engineering part. So we are deleting the unnecessary columns, for example, the URL, the dish like, the phone. Also, I am sure that PI information of the customers are not allowed to be used to build recommendation engines as well. So we make sure that we remove all the personal identification information of the customers. Then we start with the removing the duplicates. This step is also considering the fact that we are going to remove the missing values from the data set. And again, we are seeing the updated data after cleaning the data. So we have now, we are seeing there are no missing values. And the course first check the number of duplicated rows in the Zomato data frame, and then it removes all the duplicate rows as I discussed, and then it checks the missing values, and now we have all the clean data set. Now again, we are going to read that what kind of column names we have. So we have address, we have name, we have online order, book table, rate, votes. We have the location, the rest type, the cuisines, the approx cost. Uh, just just changing the column name. So I'm going to just change that, this cost to cost, this list in type, column to type. and then some transformation, and we are going to just see. So for example, the cost, we are dealing with numerical columns that have non-numerical characters like commas in the cost value. So converting the column to a string and then replacing the characters and then converting it to the new numeric format, ensure that the cost column can be used for numerical calculations. So let's see the rating part, because we are going to use it both for our collaborative and the content base. So if we see the rating part, we have the unique values. I have asked to actually identify, and we are seeing this new, which should not be there, and we are seeing that there is a decimal values, and we have this marker that it is out of 5. So let's just remove this. So we'll remove the /5, and also we'll remove the new part, which was just a error in there. So now we have the adjusted ratings. Similarly, we are going to do this. So the rate column in the Zomato data frame is also trying. So this code is primarily aimed to transforming the specific columns. So making them more consistent and suitable for analysis. The title case for the names, Boolean conversions for order, online order, and the book table, and checking the unique values in the cost column as the part of the data preprocessing step. Now let's see the clean data set. We have the Zomato head. Now we are seeing the address, the name, the online order, the book table. We have the the ratings, the votes, the location, and this. Again, now I'm trying to see the unique city, that what kind of unique cities values we have. So this is the, again, we are looking at the data set. So again, we are to ensure that we do not have any missing values. It's used to check just to count the number of missing values. So we do not have any missing values. Now with this code, we are going to calculate the mean rating with the rated column that we have just cleaned. So we are going to use the mean rating column in the Zomato data frame, and that will contain the mean rating for the each restaurant, and the loop iterates through the each unique restaurant name, calculates the mean rating for that restaurant, and assigns the mean rating to the corresponding rows. So this is the mean rating column that we have actually created. Now just scale the mean rating column. So we are going to use sklearn preprocessing min max scaler. So here we are using to scale the mean rating column in the Zomato data frame to a specified range, and then rounding the scaled up values to 2 decimal places. So this is going to just scale us. So the updated mean rating will look like this. Then some text pre-processing with the reviews. So we have 5 examples of each column before text processing. So this is the text we are having for the review list. So we are going to clean this. So we are going to first, as a traditional way, we are going to convert it into the lower casing. Then we are going to remove the punctuations, the URLs, and the stop words, and the so here we are going to remove the URLs. I'm not running this code because it will crash my system again and again. So, but it is already run. So if you will go to the Salesforce hub, you will able to run the file, and I'll upload this code as well to the GitHub, or if you want, you can just drop me a text. I'll just upload the file. So we are having the restaurant names. And now finally, we are trying to actually get the top words that extract and counts the top words from the given text column using the count vector from the sklearn. So what here we are using is that we are trying to actually, this function is useful for analyzing the most common words in the given text column, and the count vectorizer is employed to convert the text data into the format suitable for frequency analysis. So as I told, in the next part, we are going to calculate the TF-IDF score. So for that, we are going to actually use this function. So this is the sample of Zomato. Here we are seeing the shape now we are having. And this is just a pre-processing just to see that we are going to use. Now the DF percentile will contain a random subset of 50% of the rows from the original Zomato data frame. So because my system was not compatible with the fact with actually using all the data sets, so I have just taken the sample of 50% of the rows from the original Zomato. Now this part is important because here we are actually calculating the term frequency inverse document frequency. Now here we are taking this this column as the index of data frame and df percent, which we have already taken the 50 percentile one, and now we are creating the tf idf metrics here using the cosine similarities. Now here we are building a content-based recommendation system, suggest the similar restaurant based on the similarity of their reviews. So if you see, also once this is built, you can also try to actually see the particular restaurant you want to see. So if I type there that, a random restaurant name, let's see that what kind of details about this restaurant, I can type here the PyVR and I'm seeing the details of this restaurant. And next, if I want to recommend the restaurant which is similar to the user ratings and which is similar to the customer reviews to the PyVR, then the model here is actually predicting the top 9 restaurants like PyVR with similar reviews. So these are the actually restaurants the model is predicting, which is similar to the customer reviews of PyVR. Now, what I have done in here is actually I have done a collaborative model as well, just to make sure that how that will work, and just to use, because I had the user rating in this data set, so I was able to do that. So just to know, I have used the same data frame, that is the df percent, and I was just seeing that what kind of columns are there. So we have the rate column, we have the mean rating here. So I'm using the implicit, you can use the surprise library, but it was actually causing my system to crash, so I was not able to use the surprise library. With the surprise library, you can also calculate the root mean square error, but somehow it was not working on my system, so I was not able to do that. So this is the code where we are actually, so because the data set do not have the unique identification to particular restaurant, so what we have done is we have mapped the name of the with the restaurant name to a unique numeric ID, so that we can calculate on the basis of mean rating the numeric ID that we have allotted to the particular restaurant, the unique particular restaurant, and the name. So this is the based on the mean rating. Here we are performing the collaborative filtering to actually do the top 10 recommendation. So we are seeing that the Jalsa, the Spice Elephant, the San Churro Cafe, the Adhuri UDP, Bhojnalay. Now the next part of the code is actually augmentation with the GPT 3.5. So now the question comes up that why we want to actually collaborate the GPT 3 or with the existing recommendation. So my idea and my imagination was that let's for an example, you go to a store, right? And you go and you want to buy a product, and you go to nearby the product and you see all the description written, you see what is the rating and how the customer has provided the rating, and then you decide that whether you want to buy the product or not. But now consider another example where you go to a store, you walk in the store and you try to explore a product, and then there is a sales assistant standing just next to the product, and the sales assistant is telling you that what are the pros and cons of the product, and it is talking you about how the customers have liked it, what kind of interaction the customer has done, and what kind of product benefit the customer has experienced in the while. Now, in which scenarios there is the more possibility that the customer will buy the product? Majority of the time, the sale assistantship which is given to a particular product, describing all the in and out of the product, providing a very interpersonal interaction about the product, evidentially prove that it create more conversion. So here the idea is to actually leverage the GPT 3.5 model to enhance the recommendations. So because the API was not actually, my target was completed, so that is why the previous code doesn't create the output. So here we are leveraging the open AI model, and we are trying to actually create the description of the restaurant, besides with the fact that it also give a very interactive way to explain that what kind of cuisines the restaurant is offering, what kind of the main food that the restaurant is known for. And here with the recommendation, with the top 10 restaurant recommendation like 5 year, the model is also trying to give the description, to trying to give the nudge that the Burma is known for its unique culture, which combines with element of both Indian and Chinese civilization. And the most important part of the code here is that if you, let's say that here that this loop goes through each recommended restaurants in the data frame, extract the relevant information and prints it, providing a summary of the recommended restaurants along with their description and food menu description. So here the model is basically extracting the already defined and already given description of the food items, and they are trying to augment it when the model is, when the customer is interacting or trying to order the product. Also, one thing which is also very questionable here is that with the food items, there is nothing that, you know, you do not want to, you do not want the model to actually talk about. But what if that I'm doing it for a particular product on an e-commerce platform, and I do not want my model to talk about one particular product. Let's say the product have high privacy values or high confidentiality, and I do not want the model to generate context or generate any kind of content which is related to that product. So in that case, here what I'm doing is that I'm trying to generate a menu description for the restaurant jalsa, but ensuring that the generated text stop when the jalsa is mentioned. So you can also moderate the LLM generation of the text with defining the stop, that where the model has to stop for a particular kind of description of, or for a particular kind of name of the text which appears. So this is one thing that we can do. And also I would like to actually showcase here that, you know, there is one direction also I actually implemented with this code, that once the, yes, so here what the code is doing is that it's also providing the desserts and the direction for the restaurants embedded with the kind of whole description of the product. So for the 10 restaurant which the model is recommending, it is also providing the cost, the mean rating, the cuisines which they are famous for, the kind of what kind of pitch the restaurant is doing. So it is a popular style of cooking in Andhra region of India, it is characterized. Now the basic questions also which appears is why don't we use a template based description or a custom text generation model, like, you know, we used in topic modeling, or we used a simple summarization of the text. But here the difference is with the GPT, it can be very interactive. It can actually create a very kind of customer centric content when they are, when the model is describing your product. So it is very interactive in that way. Apart from that, lastly, if I say that one use case that I would like to discuss of these models, a recent case study which was actually published in IEEE conference, and it was by Karbhari et al. At 2017. And what they did is that they actually implemented a content-based recommendation model on their college, for their college placement utility. And what they did is they mapped all the profiles of the students and what kind of companies are looking for, and they created a platform where the company can just put these skills and they can find the list of these students, where the students showcase the similar profile for the company. And it was a published case. If you are interested to read the whole case, I can provide you the template, as it may not be available for all. I think, yes. Yeah, so this was the case. And yeah, so this was the actually recommendation, content based recommendation model they built. And this was something which was very useful, and which was very different from the normal business applications, where they built it for the college and for the companies. And it actually helped the college to, and it actually helped the students to get mapped with the provided job role and with the provided companies. So it streamlined the all the process. So that was it for today. I hope that you like the content, and that's it. Thank you very much. Mm.
Okay, any questions, audience? So just check, one or two question discussions were happening. I was answering, but you can add your augment
Okay.
sir.
Mm. Uh, okay. I think most of them are answered already. So distance check between. Yes, Srinivasa. Yeah.
I have one question here. Uh,
Yeah.
So with some systems like retrieval augmentation generation, through which
Okay.
product related data of a brand can be provided to GPT through in context learning. So how can
Okay.
we leverage collaborative filtering kind of system when using retrieval augmentation kind of architecture?
Um, Maybe collaborative. So I'm not familiar with the system that you actually mentioned, but collaborative filtering has a very fundamental concept where you have either user item based metrics, or either you are having item to item based metrics information. So, for example, if you want to embed something which is very dependent on user ratings, or which is very dependent on item to item ratings, then you can leverage that. But I'm not clear that what questions is it was about. If you can repeat it, if so I may understand well.
Okay, I'll probably go with an example.
Yeah.
Let's say there is one Ayurvedic brand which wants to use some sort of recommendation on an
Okay.
e-commerce.
Okay. Okay. Okay.
So, let's say a user comes and says, I need something which is related to some digestive related query, but some medicine related to digestive related query, but the user has not provided a lot of clarity there. And
Hmm.
now let's say a recommendation system which kind of wants to leverage multiple information in order to recommend right product. Because let's say
Okay.
if I have an Ayurvedic brand, there can be digestive related general,
Yeah.
digestive related specific medicines, or it can be general wellness or immunity related medicines, which can also have digestive related medicines.
Okay. Okay.
Now,
Got it.
this time when the system has to do a recommendation, one,
Yeah.
it has access to the knowledge of that products through rack, and
Hmm.
it also has access to, let's say, collaborative filtering kind of tool. So uh, in that case, how can we use that framework to specifically solve for this problem?
But I think that for this case scenario, I feel that more content based familiarity will work. Because if you are saying that if user come to a platform and the user have no idea, and they are typing that they have some disease, and they want to have look for a medicine, or they are looking for something that will solve their problem, so you can map the keywords there with the content the user is typing, rather, because there will be no way to identify via using a collaborative method. Maybe if you have embedded a neural network, then they can map with the very intrinsic or implicit inputs, that okay, that user may be preferring the Ayurvedic one. But apart from that, I think that's very rare, that if the user is unique and the user is coming and they want to inquire very different category of product, and you have no mapping already existing with that user, then how will your brand as a Ayurvedic be recommended to that user? So maybe I'm not this is my understanding. As per my understanding, in that scenario, maybe content based work more precisely.
Okay, thank you.
Okay. Okay, thank you so much for having me and for listening to my webinar. Any other discussion?
Hey, yeah,
There
this
was,
is Krishna here. Can I
Hmm.
can I ask one question?
Yes, yes, please, sir.
Yeah, it says a Gen AI and
Yeah.
collaborative model. Where is that Gen AI here? I'm trying to understand where the Gen AI is coming here in this
So
presentation.
we use the API of the LLM 3.5. So that was the only part that I wanted to augment the existing recommendation model. So it was more of a kind of how these LLMs can be used to make the models more interactive, more, as I said, that they could describe, they could provide the location of the product, so that can be more leverage in these kind of recommendation.
So you are saying in this in the code that you showed, you have used that Gen AI model here, is it?
Yes, yes, the GPT 3.5 I have used.
Okay, so does this give a better accuracy compared to the
Now
traditional one?
yeah, so I haven't checked the accuracy. I did, so I used the existing calculative cosine similarity function that I created with the whatever I've created with the TIFDI metric. So I didn't
Okay.
ask the model to calculate the cosine similarity and then recommend the 10 restaurants. I asked the model to call the function, the already calculative cosine similarity, and then recommend and then provide the description. So maybe if I ask the model to calculate on its own and then compare
Hmm.
the accuracy of the model calculation and the calculation that I did, maybe if I compare it, I haven't compared it, but that's
Okay.
something that maybe that we need to check that what will be the accuracy of both the calculations, who will be more accurate in that way. So I haven't done that in this code.
Okay, okay, fine. I was wondering maybe it's all Gen AI. Nowadays everybody is using Gen AI, right? So I thought maybe it is
Yeah.
proved to be better. Compare accuracy is
Yeah,
better.
I will
It
definitely
need
look
to
upon
be
that.
okay.
Yeah. But
Okay.
one thing I just keep on wondering, that if you have a very product, you are not open with sharing your product details, then you may not be able to share your, the item description with the GPTs. So in that scenario, you may already want to calculate with your, preferential models, maybe the content base or any other model, and then you may call the GPT to just leverage the already existing function and then just augment it with whatever function you want to allot to the GPT. But it depends. Yes, definitely I'll look upon that. I'll try to compare the accuracy of the model of the both.
Okay. Thanks. Yeah.
Um, any
Okay.
other?
Well, let's see the messages. Is there any questions on messages?
Any ideas where ChatGPT can be used with testing? Um, with testing of the models, maybe I think I may have uh, skipped that part, but definitely I'll look upon that if we can do a testing and we can compare the different uh, values of the model. So I haven't done that, but I will try to do that. So Pooja has the question, any ideas where the chat GPT can be used for testing? And I'm assuming that the testing part comes up with the accuracy of the model, like the root mean square error we discussed, that what effect the GPT will have on the root mean square error. So I haven't calculated that, but I will do that definitely. So if you want to have such interaction, or if you would like to have more information about about the present webinar, you can also ping me on LinkedIn. I will be available there. I'm active there, so we can discuss whatever suggestions I have gotten. I can also share after performing the suggestions if someone is interested. Apart from that, thank you so much. Um, yeah. Any other question, Vivek?
I think that's about it. Thank you very much. Very interesting webinar. Audience, thank you for joining. Thanks, Sunny.
Thank
And
you
look
so much.
forward to your future sessions as well.
Thank you so much for having me. Thank you.